Good day. Welcome to YeboTutor live stream hub. It's been a minute. It's been a second. I hope you guys wrote paper one well yesterday. So today we're gonna do like a mock preparation exam for your test, which you guys are writing your paper two on Monday, which is a chemistry. So we are looking at a paper which was written last year for physical science, paper two, which is chemistry. So without wasting much time, let's go straight into it. Of course, you know that you have your organic chemistry and you have your multiple choice answers. You would do that one, not bad. If you need the question paper, join the group using the description of the video which we have right now. Then we'll be able to send the question for you so that you can also be able to practice and ask the questions on YeboTutor live stream hub. Let's look at question 2. Consider the organic compounds A to E below. We are given A, which is 3-methylbutanone. We are given that one with Cl. We are also given structural compounds, as you can see on C and D. We are also given E over there. Great. Now define the term functional group. What is a functional group? Guys, this is not bad because we know that a functional group, it is always a bond. It is a bond, or you can say an atom or a group. Okay, so you can choose either. So you can say it's a bond, or you can say it's an atom, or you can say a group of atoms. That determines the physical properties of a group of organic compounds. Just like that, your life will be good. Get your 2 marks. Now, write down the letter of the comma that contain a carboxyl as group. That's easy, guys. We can see that that's going to be on E because this is what contain that carboxyl group there. As you can see, we have a double here for carbon and oxygen, and also we also have an OH over there. Now, here's the general, or write down the letter which is the general term CnH2nO. We can see that will be on this is 3-methyl butanone. Yes, so that will give us that general, because we know the general terms. This is a ketone, as you can see. This is a ketone. So since this is a ketone, we know the general formula for that. So that will always be CnH2n0. Then here's an empirical formula of CH2. CH2. Which one we have that empirical formula, which you need to solve that part, and for us to see which one has the empirical formula of CH2, that will give us on C over there, and we can see that's just an alkane. So that will give us that specific empirical formula. So our 2.23 is on C. Now, how will the molecular mass of compound E compare to the ethyl methanoate? This is now an ester, right? So since this is now an ester, now I want to compare compound E, which we have here, to our ethyl methanoate. Choose greater than, smaller than, or equal to R. Definitely this is going to be equal to Y, because we can see that compound E and the ethyl methanoate are just functional isomers. Others could have said maybe they are structural isomers, okay? Which means that they have the same molecular formula, of course. Or you can say that it has this the same number of atoms. Which atoms are we dealing with? We have the C, we have the hydrogen, and also oxygen. So we can see that this they will be equal to, because they're just isomers, and that makes our lives a bit easier. Now, write down the structural formula of compound A, that ketone which we're speaking about on compound A, which we say that it belongs to this general formula here. So how do we write down the structural formula for that? This is not going to be bad. It's just going to be easy and straightforward, because we already know how to navigate our way on that and how we can save and have our answer on that. Easy stuff. So we can see that is our A. We are given our methanebutanone, which means we are looking at 4 C's here. So we have 1, 2, 3, and 4. These are our 4 C's, and of course it's a ketone, so we need to have our oxygen over there. Then of course we have our C, and of course we have our H, and H over there. Then again it goes there. Then of course we're gonna have our H. We're also gonna have, they say that 3, which means if we are counting, which means there's a methyl there at 3, so that can be 1 2 3, so which means we can have another C here. Then of course we have that to have its bond on hydrogen as well. Then of course, as always, they should have 4. Then our life should be easy. That's all, guys. So we listen and we can see that this is our parent chain, and since we know our parent chain is coming from the left, so from the right, we can see that this is coming from here. So it's 1 2 3. That's where there is that 3 methyl, because that's where it is. And we can see that here it is where our functional group is there, so that we can be able to get the proper answer. So this part is very crucial and very, very important. Now do a IUPAC name of compound E. IUPAC name, which means we need to name this compound E which we have here. Let's check compound E. We have 1 2 3, which means we have 3, and we know that on number 3 we are looking at prop, but we can see that this is a carboxylic acid, and we can see that at 3 that's prop, so we're gonna have this to be our proper noic acid. Okay, easy stuff, because you can see it's 1 2 3 3 carbon atoms which we have. Now I'll give you the IUPAC name of compound D. Yes, compound D. We have 1 2, we have this 3, which means this is an alkene. All right, the moment we see this 3, this means this is an alkyne, right? This is an alkyne because of the 3 bonds which are there. So we can see that we have 1 C here, we also have 2 C's over there, and there will be a double bond on that one as well. So we can now be able to see that. And if we can see this is 1 2 3 4 5 6. Okay, because if you can take this again, it's gonna go down. This is going to be on this position, it's gonna be C, then it goes to another C, which is 1 2 and 3, but this one is 2H2 only, so it's 1 2, then we have a double bond also here, so it's now 1 2 3 4. So now we can be able to do that, and can be able to get that. So you can see that the longest parent chain we have is going to be on position, it's 6. So when it's 6, what do we know? When 6, we know that we are dealing with a hex, but because of this now we know that this is in position 1 2. So now we know that we have hex at position 2, because this is an alkyne. Now we need to check now our functional isomers, sorry, our extended things which we usually have. So you can see we have 1 here, and it's in position number 4. 1 1 2 3 4, we have that. We also have this other one as well, so we're gonna say this is 4 methyl, as you can see, hex 2YNE. So this will be our correct answer. So what is important when you're doing the IUPAC naming, you need to know which specific compound are you dealing with. The moment you know which compound you're dealing with, the moment you can be able to get your correct answer over there. All right, this is just how we solve this thing, guys. So please go over the organic chemistry as your compound B is a secondary haloalkane. Now draw the structural formula of compound B. Compound B is given as C3H7Cl. Now they want us to draw this specific, so we can see it's CH7, so we can have 3 C's there, as you can see over there. Then of course we can have our Cl over here. Then of course other ones will just give us our C's, so it's 1H, 2H, 3H. Of course we have another H, we have another H, we have another H, and another H. So that would be our structural formula for that, because that's an haloalkane. Now using the molecular formula, write down the balanced equation for the complete combustion of compound D. Where is compound D? Here is compound D, a complete combustion for that using the molecular formula. So we know that if we're gonna write a balanced equation, we're gonna have our CH7, sorry, we are having our C7H12, right? 1 2 3 4 5 6 7. Yes, we have CH is there. Then of course plus our oxygen, because they say combustion, this should produce of course our carbon dioxide plus your water over there. So now we have to balance this equation. How do we balance this equation? We know this already. We can see that we have C7 here, we have 1 on the other side, so we need to have 7 on both sides. So now it's 7 7, but now we now have 14 oxygen plus that one 13, and on the other side we only have and we also have 12 here, whilst this other side we only have 2. So if we put 6 here, that will now give us 12 hydrogens, and now we now have 14 plus 6, now we have 20 oxygens. Now on this side we only have 2, so we need to put the 10 so that we can now have 10 oxygen. So now we can now see that our equation is now balanced. Just like that, we have 12 H's, we have C7. The moment they say a combustion, which means it's reacting with oxygen gas there, so that needs to produce carbon dioxide as well as our water over there. So that will give us that specific equation which we have on that specific point. Now going forward and trying to solve the next question that follows, now we can see that on 3.3 now where we are, the relationship between the boiling point, this is a very critical thing. Now definitely they might ask you what is the boiling point, the melting point, or the vapor pressure, and the number of carbons in a straight line. Okay, chain primary alcohols, so we can now highlight this will be having primary alcohols are being investigated. So look at what we are given. So we have the boiling point in Kelvin and also the carbon number of carbon atoms which we have. Right, define the term boiling point. Guys, we know that the boiling point, it is the temperature at which the vapor pressure of a substance, or perhaps you can just say the vapor pressure of a liquid, is equal to the atmospheric pressure, just like that. So the boiling point, it is the temperature at which the vapor pressure of a liquid or a substance is equal to the atmospheric pressure, just like that. You'll be good. What is the structural similarity between alcohols, between the alcohols, that makes this a fair decision? What is the structural similarity? So we can see that all of them, they are primary alcohols. They told us that, because we know that we have primary and secondary. Those are the structural things which we can look at when we're looking at this specific one. Sorry. Which van der Waals force is responsible for the trend observed in this? Guys, this definitely is going to be our London forces. Okay, our London forces. Others might say our dispersion forces. Others can also say these are our induced dipole forces. Okay, write down the IUPAC name of the alcohol with a boiling point of approximately 410. So 400 is here. Let's see each box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, which means the box is 10. So 410 will be 400, 410. So here is 410 coming to this point, and this point is coming with 5 over there. Can I double check that as well? Double check that. 410 somewhere here. Oh yeah. So here's 410. Here's your 410. We go with it. We go with it. We go with it. We go with it. So around there. So you can see that is going to be 5 number of carbon atoms. So we're gonna have 5 C's over there. And of course they say that which will make this specific thing at 410. So we have 5 carbon atoms, and we know that that can be written as pent. So this can be pentane, of course, all, so that you can see that we have that primary alcohol which we have there. The moment we looked at, we saw that the number of carbon atoms are 5, and 5 is pent, and it's 5 polygons. We have polygon, pentagon, and all those kind of stuff. But when we're looking at alcohols, the moment we are at 5, that's also a pentane. Then of course we have 1 0, which means that's where there will be that bond there of the OL right now, which we usually have. Now, another investigation is carried out to determine the effect of structural differences on the boiling point. Okay, we want to find the structural differences on the boiling point. The table below shows the different compounds and their respective molar mass that was used in this investigation. So you can see butane, this is a ketone, this is a beta, or that's an alcohol, this is your carboxylic acid because it's a propanoic acid. Which compound A, B, C will have the highest boiling point? Guys, definitely is going to be compound C. It will have the highest boiling point. As you can see here, propanoic acid, it will have the highest boiling point. Okay, highest boiling point. Now fully explain that for 5 mass, because definitely guys, we can literally say that the type of the intermolecular forces in A, and also we can see that compound B and compound C, these two compounds, they have our hydrogen bonds. So compound B and compound C, they have hydrogen bonds. So now we can see that if we now compare that, the strength, the the propanoic acid now we have the greater strength in terms of their intermolecular forces, which means that that will need more energy to be able to overcome those hydrogen bonds. So that's why it's going to have that highest boiling point, as you can see. Because if you can check the first one and also look at other ones, the first one, J, it has its own intermolecular forces, as we have already highlighted that, like we have like London forces and induced dipole forces. But if we look at compound B and compound C, we can see that they have hydrogen bonds. Now that they have hydrogens, now we can now be able to compare the number of sites for the hydrogen bonding in both B and C, and now we can also be able to compare the strength of the intermolecular forces which we have. Then now we can now be able to see the energy required to overcome the intermolecular forces between them. Question 4, new question, new thoughts. Let's see what the question 4 is asking us about. So you can literally see that there is no way we'll be able to fail when we are writing, because at least we know that this test we are writing to on Monday, everything should be ready to go and we should be able to pass. Now consider the 3 organic reactions 1, 2, and 3 below. Okay, we can see that this is an alkene, of course. Okay, let's see. Is pent 1 in saturated or unsaturated? Give a reason for the guys, come on. Everyone knows when we are speaking of an alkene, which we have there, everyone should know that this is an unsaturated, right? Because it's an alkene. Why are you saying that? Oh yeah, write down the type of reaction represented by. Okay, give a reason for your answer. Of course, because it contains a double angle. Sorry, I'm used to mess. A double bond between the carbon atoms. If you still remember on alkenes, like this. So that double bond there is what makes it unsaturated, guys. Now write down the reaction represented by reaction 2, organic compound P plus the sodium hydroxide, giving us a secondary alcohol, and that sodium chloride. Definitely this is going to be your substitution, or you can say hydrolysis of haloalkane. Okay, so this is a substitution, or you can say that it is your hydrolysis of what? Of a haloalkane. Now reaction number 3, this is organic P and that sodium again, producing that major product plus salt plus that. Definitely this will be your dehydrohalogenation. This will be your dehydrogenation. So please go over your what do you call this, your organic chemistry, especially after the moment you start from esterification, going through all these different reactions which you have. Please go over them, they are very important. The moment you know what's going to be produced, the moment you can be able to know and still remember these different reactions which we have. So this is going to be dehydrogenation, or someone will just say this is what, this is your elimination, right? This is the elimination process, but which elimination is it? This is dehydrogenation, which means we are looking at the dehydrogenation of the of the haloalkanes over there. All right, let's look at the next question which follows over there and see if we are all together on that. Next question that follows says that write down the structural formula of compound P. Let's look at compound P. This organic compound P is repeated in all the instances. You can see that from pentene plus this is producing this compound P, and that compound P is repeatedly done. So now they say that write down the structural formula of compound P, guys. What will be the compound P? So this, of course, will have your 5. So this is 1, 2, 3, 4, 5. Because of pen, that's 5. Then of course we can see it's engaging with that HCl there, which means we're going to remove that. So that will be our structural formula, which is 1 2 3 4 5. Then of course that we can see that we have that double at 1 there, which means that we can also have our Cl there, which we can put maybe around here, position here. So we have our Cl over there. Then of course we can now have our different H's. Bond that with our H. As you can see, everything is bonded now. All right. Now write down the IUPAC name of compound Q, the secondary alcohol which is produced. Definitely this is easy. As you can see, this is just going to be your pentane 2. Oh, okay, for that specific alcohol which will be produced there, as you can see, because if you see that this is our compound which we have here, which is at 1 2, just remove this and substitute that with our alcohol which we're gonna form there, the OH over there. So that will produce that pentane 2-ol. Now the pentane, oh okay, write down the condition that will prefer reactions 2 over reaction 3. All right, if we look at reaction 2 and 3, they require use of strong base. Okay, so what will make these two different, and what will makes us to be able to choose the condition that will prefer reaction 2 over reaction 3? This is quite not bad, because you still remember those different reactions which we have. So we know that the first one will be our dilute strong base, which is in this instance your NaOH, or maybe, and since it's 2 marks, you can also include mild heat. Those two will be able to enable us to prefer reaction 2 over reaction 3. Now we are given the pent 1-in and organic compound R are isomers. Let's check. Where is R? Okay, this is the isomer. Okay, they are isomers to each other. Now what type of isomer is pent 1-in and organic compound R? Which isomers are that? Definitely they are positional isomers, because what changes is just the shift of the position on which we have that one. So that will just be your positional isomers. Where we have the double bond is just shifted on that instance, so that's why they are that. Now we are given the flow diagram below, which shows the conversion of butane 1-O. This is 4 carbon atoms, and O, that shows that that's an alcohol, to butane gas, right? Now the following chemicals are needed: concentrated sulfuric acid, which is H2SO4 PTH2. Using condensed structural formula, write down the balanced equation and indicate the chemicals used in each step. They need this as condensed structural formula that will be able to do and assist in preparation of butane gas from butane 1-O. Okay guys, this is quite easy. We can write this properly and fast. Okay, in order for us to do that, we need to look into 2 different things, because they say that using this, now write down the balanced equation and indicate the chemicals used in each step of the preparation. So we can see that reaction 1, which occurred here in this instance, let's write this here. So if you can say reaction 1, the first reaction which happens here in this instance here on our 4.2 is, we understand that we have different things which we have. We have our dehydration reaction, and also we can see that the reactants, they have the condensed structural formula, and also the products with the correct context. So if we can see this one, we can literally see that this is going to have our reaction 1, which is going to have our CH3 CH2. Of course you have your CH2OH. Then of course, with heat being there, and of course we have our concentrated H2SO4. This should produce our CH3 CH2 CH. Okay, CH2, then we have CH, then we also have CH2, then of course plus your water being produced over there. So this is the correct reaction. Now you just do this in the structural formula. We know that CH3 is 1, then you have your that, then you have your C, which is only 2, 1 and 2, which is 1 2, and of course we now have another C here, which is also have 1 2, which means there's a double here, so it's 1 2 3 4 1 2 3 4. So it's CH2. Let me check something. So that will be, this is bonded with 1 2 3 4. What about this one? So it's, yeah, something like this. Let's see. So that'll be 1 2 3 4. 1 2 3 4. Yes, as we go forward, we go and do the same thing. We have our CH, so that'll be 1 2. Then you have the O and H over there at the end. So that's you just doing that on your own as well. Then for reaction 2, which is our addition reaction, that will give us our CH3, CH2, CH2 plus your H2, and of course we can see that we have that PT there. We need to consider that. So that PT is going to be acting like a catalyst for us over there, and of course overheat, and this will produce our CH3, CH2, CH2, CH3. Of course that will be produced with reaction number 2. So you're gonna get 3 marks for this one, and also get the 3 marks for other one. Please don't forget that water is produced in reaction 1 because we are looking at dehydration. So that water should be there and should be illustrated in that specific example, which we are doing over there. Now let's proceed to go to the next question, which we are given. In this instance is going to be question number 5. Now the reaction between excess, okay, this is important, hydraulic acid, okay, with zinc is used to investigate factors influencing the reaction rate, the balanced equation. So this balanced is given, and also what is important, we're given that the delta H is less than 0. Now the 3 experiments are carried out and 1 factor is changed in each experiment. The same volume of hydrochloric acid and the same mass of zinc granules are used in each experiment. The hydrochloric acid completely covers the zinc in each experiment. Now this is the table which we have. We have experiment 1, 2 and 3, and you can see the concentration of the HCl, hydrochloric acid, which is 0.5, 0.8, 0.5, and of course we can see if the copper is present, Cu there. So we can see that no, and it's only present in experiment number 3. Now define the term reaction rate. Reaction rate is the change in the concentration of reactant, or you can say the product, and of course per unit time. Easy stuff. It is the change in this specific rate of change, reaction rate is the change in concentration of the reactant or the product per unit time. Someone can say that this is the change in the amount of mass of products formed or the reactants used per unit time. Okay, then you can be able to still be in the same line and still get the correct answer over that. So that's very important. Write down an investigative question when comparing experiments 1 and 2. We can see that both these are not present, but the difference is in the concentration. What can be the investigative question which we can create based on what we have here? Maybe we can say that what is the effect of the increase or decrease or change of concentration on the reaction rate? That can be because we are looking at this, and this is what we are told to do when we are looking at this specific investigation which we have here. So we can now say that the investigation question can be saying that what is the effect of the increase or decrease, or the effect of the change of concentration, okay, on the reaction rate, as you can see, because there are difference here in terms of the concentration, whereas both they don't have CUs that are present. So let's see that can be our investigative question. Now the curve which is not drawn to scale is obtained for the volume of hydrogen gas H2 produced over time in experiment 1. So this is the graph. You can see it's T1, T2, T3. Now, how does the rate of at which hydrogen gas is produced between T1 and T2 compared to that of T2 and T3? How will this affect the rate? How does this affect the rate? Write down only higher than, lower than, or equal to. Definitely it's going to be higher than, guys. All right, definitely, with no doubt, this will just definitely going to be higher than. Okay, now redraw the graph in the answer book. Clearly label the curves as A. On the same set of axes, sketch the curve that will be obtained for experiment 3. Label this curve as B. So this graph is going to be just a nice proper graph which we have. because we know that we're gonna draw this as it is, and of course this is our A as we were given here. Then our B now, since we said higher than, it's gonna be something like this. Okay, that's not nice. There we go. So this is now B. And of course, we know that this is the volume of the hydrogen gas, which is in meter cubed. And of course, we know that this is your time. All right. So that will be the function. That will be the function then. That will be the graph. Otherwise, A, what we are given, and B is the one which shows a bit high, since we said higher than over then. Now on 5.4. Wow, there was no. Okay. Let's go. Now, the reaction in experiment 1 takes 58 seconds to reach the completion, and the average reaction rate at which hydrogen gas H2 is produced is this. All right. That's different. This is showing that this is centimeter cubed over a second. Okay, great. Calculate the initial mass of zinc used in each experiment. The molar volume for hydrogen gas H2 at that is 24 that. So again, we're given centimeter cube over mole. Okay, all right. Experiment 4 is now conducted. So now we are just doing this part first, because they say calculate the initial mass of zinc. How do we calculate the initial mass of zinc, guys? Easy stuff. What do we know about this question? We know that, let's open a new note there so that can be able to write. Okay, on this specific question, we need to write on a big page. So on this instance, we can see what we are given there. So we can literally just say that the rate, as we know, rate is always equal to your change in volume over your time. And the change in volume is just going to be your V minus 0 over your time, which in this instance you're given is 58, right? And what is rate? The rate is what we're given is 8,39 here, as you can see, 8,39 centimeter to that. So now we can now be able to see that if we make V the subject of the formula, V will now be equal to that 8,39 multiplied by 58. Then now I end up getting my 486,62 centimeter cubed. Now that I have that answer, now I can now calculate whatever I want to calculate. At STP 25 degrees Celsius, we know that we can have number of moles N, which is equal to V over the Vm, and our volume we have calculated it to be 486,62. Then we divide that by the 24,000, which we are given over there. Then of course we can now be able to have the number of moles for H2 is going to be 0,02 more when you divide that. Now from that point, now that we have that, now we can now be able to have a better life now, because we can at least know how much do we have on that. So now that we have that part there, now we can now be able to just equate this and have the number of zinc. As you can see, zinc and H2, it's 1:1 in terms of their reaction. Zinc and H2, you can see it's 1:1, which means the number of moles of zinc and the H2, they should be equal to each other. So then therefore we can see that the N H2 is equal to the N of the zinc, which we are playing around with, which is equal to your 0,02. This is where we have done that mole ratio there, so that we can be able to get that. Now then, therefore, now we can now be able to calculate the mass, because we know that N is always equal to the mass over the molar mass. What is N? N we already know, and what we want to calculate is M. So M will now be N multiplied by the molar mass. And your N in this instance is 0,02. And what is the molar mass of zinc? Always using your periodic table, it's always going to be 65. Then you multiply the two, then you should be able to get 0, it's 130, but 1212. So that will be 1,30. And of course, we know that this will be in grams. Then you get your 5 marks for being able to solve that part over there. So please don't forget that the reaction rate is always equal to, let's go over our answer again. Reaction rate is always equal to change in volume over the time, change in time. So the moment you understand that, the moment your life will be beautiful, because this is what led us to be able to know how to get the volume. After we got the volume, you can see that we are given the standard temperature there, and also we are also given the standard volume there, which is Vm in this instance, and this volume is just given as 24, that one. So we use that one, and you can be able to get our number of moles. Then we did a mole ratio there, and we can show that zinc is to H2 was just 1:1. So the number of moles of H2 is equal to the number of moles of zinc. Then you can be able to equate both to each other. All right. If you have any question, guys, please stop me. I'm not seeing any question in the comment section. I want to hear people asking me questions so that at least I know that we are all together and we are cruising together nicely, because to me it's cruising nicely, but I also want you guys to cruise nicely as I am doing as we prepare for your Monday exam. Okay, let's close that. Perfect. How would this change the reaction rate? Okay, experiment 4 is now conducted by increasing the temperature. So the temperature has been increased of the reaction in mixture of the experiment 1. How would this change the effect? Definitely, guys, this will increase because they've increased the temperature. Explain your answer by referring to the collision theory. Definitely, guys, at higher temperatures, the average kinetic energy of the particles is higher, which means that there will be more particles that will have enough or sufficient kinetic energy, or more particles have kinetic energy equal to or higher than the activation end, which means that there will be more effective collisions per unit time, which will, okay, that's perfect. Let's look at question 6. What's the last question? I'm tired and you guys are not speaking with me. Like, question 9 is the last question. Okay, let's look at question number 7. Okay, let's start with question 6. Because of the following hypothetical reaction at equilibrium. Okay, we can see that's irreversible. These are the two temperatures. Now state Le Chatelier's principles. Guys, Le Chatelier's principle is going to be asked in your test on Monday, even if we like it or we don't. That is going to be asked. You need to know how to define that. And how do we define that? We say that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium. When you disturb the equilibrium in a closed system, the system will reinstate a new equilibrium by favoring the reaction that will oppose or that will cancel this exact disturbance which we have. Please take note of that. Is the forward or reverse reaction favored at 200 degrees? Definitely we can see that the forward reaction is favored, and the reason is that the equilibrium concentration of B is higher than of A, so that's why we can see that it is favored. All right, you can see that the concentration here and here, this one is bigger than this, which means this is going to be the forward reaction, because we can see that the concentration or the equilibrium concentration of B is higher than that of A. How would the equilibrium concentration of A at 200 degrees Celsius be affected by the following? Choose from increase, decrease, or no effect. If the pressure is increased, guys, when you increase the pressure, definitely it will also increase. If there is an addition of a suitable catalyst, definitely there won't be any effect, because the catalyst is there to speed up the reaction. So this will just be no effect over there. Now, is the forward reaction exothermic or endothermic? Let's check that. Definitely we can see that this is exothermic. Now, using Le Chatelier's principles and refer to the data in the table to explain the answer to your question 6.1. But why are we saying exothermic? We are saying exothermic because we can see that the concentration of A increased and we can see the concentration of B decreased. As you can see here, at B, the concentration decreased, at A, it increases. So now, that's the first point, because we are using Le Chatelier's principle. So according to this Le Chatelier's principle, it says that if we increase the temperature, it favors the endomethic reaction, which means the reaction which is in the reverse will be favored in this instance, or the equilibrium position is shifted to the left or to the reverse. Now, initially we have 1,05 moles of bromine sealed in an empty container. The following reaction occurs at 1,600 degrees Celsius. And of course, we are given our equation, which is here. At equilibrium, the concentration of bromine is 2, that. Okay, that's good. The equilibrium constant Kc is given as that. Calculate the volume of the container. So this is quite an interesting one. They already given us Kc. How are we going to calculate the volume? And this is 8 marks, guys. This is quite a good question. We know that Kc will always be equal to that for the output, which is Br, right? So Br now will be squared. Then we divide that by just your your Br gas there 2 over there. So we know what is our Kc. Our Kc is given as 6 comma that, so that will be 6,34 times 10 to the power negative 4. Of course, we multiply that by our 2,074. Then now we end up having the Br squared. Then of course we need to put the square on both sides so that you can be left with the Br. So using your calculator as I'm using mine, I'm getting my answer to be 0,03626. So that will be the Kc value of that top there which we have. So if we still remember how to do Kc, we know that when you're applying or solving the questions which has to do with Kc, we can have our initial concentration. So this can be your initial concentration. Then of course you can have your change in concentration. Then of course you can have your equilibrium concentration. So you can have that in terms of those things. Then of course we still know that we have our Br squared 2Br. Now we can see that initially we are given this initial concentration to be 2,09293 2,09213. Okay, that's what we are given there, and we can be able to calculate the other one because we know how to find the concentration. We know the number of moles for that, so we can be able to calculate that because we know that. So the number of moles is always equal to N over that, so we can be able to calculate the concentration because C is always equal to N over V. So that will give us that 2,0,923. Why are we getting, or where are we getting that answer? Because we know that C is got N over V. And what is our N? Our N is 1,05. What is our V? Our V is the volume, and our V is going to be, in this instance, what we need to calculate over there, and we can be able to get the concentration. Now again, you can see that we can be able to get the equilibrium constant as they told us is 2,04. So we have our 2,074 over there. Then of course we can also have our 0,03626. Then of course we have our change. It's just going to be the same for that. It's going to be 0,03626. Then of course we're going to have our 0,01813. Then from that point, now we can definitely be able to get that and can be able to get the concentration which we were looking for in this specific question. Alternatively, you can calculate this using different methods, but this Kc methodology is the important one. You start by using calculations for the Kc, then you get your value for Br. After you get your value for Br, then you multiply that by 2, you end up getting the answer which we almost got there. Then after that, you can be able to have a nice proper life. Okay, question 7. Sulfuric acid, as we can see, is a strong acid that ionizes in 2 steps as represented in the equations below. This is step 1. It's with water, then it produces that and that. Now, what is meant by a strong acid? Okay, strong acid, it ionizes completely in water to produce a high concentration of the hydronium ions, right? So it produces these ions which are written as H30 plus. So this is a strong acid. Now give a reason why sulfuric acid is referred to as a diprotic acid. It is written, or it is regarded as a diprotic acid because it donates 2 protons, which is your H, right? Donates 2 protons. That's why it's called the diprotic acid. Write down the conjugate base of H304. Definitely your conjugate base is just going to be your water, H20 over there. Write down the formula of the substance that acts as an ampholyte. Oh my word. We can always know that in order for us to ionize this, it's going to be your H2SO. SO4 in this instance, because that's what's going to act as an ampholyte. An ampholyte is something that can act both as an acid as well as a base. So that is a proper one as well on that. So we can choose that one to be our answer over there. Now calculate the pH value after the complete ionization. We are given the concentration of the sulfuric acid to be 0,1. Now they want us to calculate the pH value. So this is quite easy, guys. You can calculate this easily because you guys are smart. So I'm going to give you that as your homework to guys to do that. But of course, just because I'm a good person today, we can see that if we look at this instance, we can see that our ratio is H30 plus is in the one for our H2SO4 minus. You see they're equivalent to each other, which means our pH here is just going to be pH is equal to negative log of our H30 plus. Then of course we substitute there, then we can be able to get our answer. So that will now end up giving us our pH, which is equal to your negative log of course your 0,2. Where is 0,2 coming from? Because we know that the concentration of sulfuric acid is 0,1 and 0,1, and now we are looking at H30 there. That will multiply that by 2, then that will be 2 times 0,1, then we end up having 0,2. So that will give us the H30, which is the hydronium ions. Then now you can be able to get your Kc and you can use your calculator. Now 7.2, that's going to be a homework. This looks like a homework question because that's where we want us to do titration. Let me give you that as your homework. So please make sure that you try to do and attempt that question on your own as your own homework. All right, so that at least we can be able to engage and get correct answers together as one and as a team. So we will end up here today so that at least we can be able to understand what's really happening with the work. So we'll end up left with question 8 as well as question number 9. So these two, please text me in the group so that I can be able to send you these 2 questions for you to practice. Then you can solve these 2 questions on your own time. Other one, state the energy conversion that takes place in the cell. Come on guys, you already see what is the energy conversion for that one. So this one is quite easy, but I want people to ask me in the group so that I can see that people were listening and they're able to reach to this point. Then after that, can be able to see, because in this instance we can see that there is a chemical energy to electrical energy. And now what is compound Y? We know that our compound Y is something which is very important there, because it have a great importance. As they say, state one function of that, we can see that it provides the path for the movement of ions. As you can see that ions are able to move from the left to the right, or from the right to the left, because of that specific compound Y. Write down the reaction, half reaction, which means now you're using your book. As you can see, we have Fe2 plus there and Fe3 plus. So that will be easy. That you're just going to be your half reaction, which is Fe3 plus your E minus. Then of course producing that Fe2 plus. Okay, where is this coming from? This is coming from our table, which will be given in our exam. Here we go. This is where we get our half reactions over here. So guys, please make it a point that you remember this, because this is very crucial and very vital for you guys when you are solving your problem. This is where you get your half reaction. So do this as your homework, guys. As you can see, ask me for this question paper in the group so I can, or drop your comment, and then I can be able to send you the question. All the best, guys, as you prepare for your test, which you guys are writing next week. I just wanted us to prepare and do a couple of questions on that specific work so that at least people will be ready in the preparation for their test. Thank you so much. If it's your first time to be on YeboTutor platform, please do us a favor and yourself a favor and subscribe and like and comment. If many people ask questions for question 8 and 9, I'll be able to stream live tomorrow just before you guys write on Monday. Then our live should be later. Thank you so much, guys. Have a good, beautiful day. I